The electrical activity that is associated with the function of the brain and recorded on the scalp is called the electroencephalogram, or EEG. Here you can see an example of an EEG. EEG uses typically a few electrodes that are located in well-defined positions on the scalp, and they reveal information of what's going on under these electrodes. As the scalp is highly attenuating, there is not a lot of spatial selectivity offered by an EEG recording. In order to get more information on, for instance, the sleep-wake cycle of the premature baby or its brain development, often the aEEG is being used, the amplitude-integrated electroencephalogram. An aEEG typically has a limited number of channels, 2 or 4. Here you can see that recording is made in position 3 and position 4. It is derived from a raw EEG. However, contrary to a raw EEG, time and amplitude are compressed so that they reveal more information over a longer time span and also between smaller and bigger amplitudes. From 0 to 10 microvolts, the scale is linear, and from 10 to 100 microvolts, the scale is logarithmic. Here you can see an example of such an aEEG, and what you can see is that here, between 0 and 10 microvolts, the scale is linear, whereas from 10 to 100 microvolts, the scale is logarithmic, and thus it reveals more fluctuations in more detail. The electroencephalogram is being recorded by means of electrodes, of which there are two types. There are the surface EEG electrodes that use an adhesive gel and also a large metallic surface for the recording. But there are also, in order to get better contact, there are subdermal EEG needle electrodes. Although they look a bit pointy, they damage the skin less and usually have a higher reliability when it comes to signal quality.